In this video, we're going to be discussing similar figures. Now, to begin, you will need 5 different colors. You can choose between pens, markers, crayons, or matte pencils. And what we're going to do with these colors is we're going to color their corresponding sides the same color. Now, remember, this word corresponding means same position in a different shape. So, again, we're going to go ahead and get into this and look at number 1. So for number 1, it says Marta wanted to find the height of a tree by placing a stake in the ground to make a shadow, which could then be compared to the length of the tree's shadow. Which of these proportions could Marta use to determine the height of the tree in feet h? So we are looking to see which one of these proportions can correctly determine the height of the tree in feet. And we're going to determine this by first setting up a box and tail. So draw yourself a box and tail. And here we are comparing the height and the shadow. So I'm going to put height and shadow as my labels. And I again like to keep myself a bit more organized. So up top, I'm going to label this as the tree and the stake. After I do this, I'm going to go ahead and identify what is the height of the tree. Well, the height of the tree is h. The shadow of the tree is 29 feet. The height of the stake is 5 feet. And the shadow of the stake is 8.5 feet. So when I come down here and I'm trying to determine the correct proportion, I am looking for the one that cross multiplies and divides correctly. So I'm looking for the proportion that cross multiplies 29 times 5 and divides by 8.5. So when I look at F, I'm cross multiplying 8.5 times 29, which I know is not correct. I can automatically eliminate F. For G, you're cross multiplying 8.5 times 5 and dividing by 25, which again is not correct. We have to cross multiply 29 times 5 and divide by 8.5. So G is also incorrect. When we look at H, they are cross multiplying 29 times 8.5. And again, on the proportion we created, we should be cross multiplying 29 times 5 and then dividing by 8.5. So H is also incorrect. And lastly, we look at J. On J, we are cross multiplying 29 times 5, which is what our proportion has, and we're dividing by 8.5, which is our correct proportion. So again here, J is the correct proportion that cross multiplies and divides correctly. So that was number 1. Now we're going to need, go ahead and look at number 2. So for number 2, it says figures 1 and 2 are similar quadrilaterals measured in units. We want to know which proportion is true. So to determine which proportion is true, we're going to create a proportionality ratio. And we're going to do this by comparing the sides of figure 1 to figure 2. Now this is where you will need a few different colors. So I'm going to go ahead and start off with blue. And I'm going to go ahead and start off by highlighting this side here, which is 7.3. Now, I want you to notice that the side where 7.3 is connected to the angles that's marked with 1 angle measure and 2 angle measures. So when I go over to figure 2, 4.38 is going to be its corresponding side. And again, remember, corresponding means same position in a different shape. So these two sides are corresponding to each other. Then I'm just going to go around my quadrilateral. So I'm going to now look at 5 in figure 1. And its corresponding side, remember, same position in a different shape. Also remember that these figures are rotated. And you're now looking for the side that is connected to that 90-degree angle like it is in figure 1, and that's going to be side W. So 5 and W are corresponding. Then I have side V in figure 1, and its corresponding side is going to be the base here on figure 2, which is 6. If we continue, I have 4.2 in figure 1, and its corresponding side is 2.52 in figure 2. So now what we're trying to do is making sure that on our proportion everything is diagonal from each other. So for instance, if I look at A, I should have V and 4.38 diagonal to each other. So when I have V and 4.38 diagonal, like I do here, I should also have 7.3 and 6 diagonal in my proportion. So yes, I do have V and 4.38 diagonal, but this is good, I do not have W and 5 diagonal when V and 4.38 are diagonal. I should have 7.3 and 6. Another way you can go about looking at this is color coding your answer choices. So for instance, V we have as green. Okay. And then 5 we have as pink. W we have as pink. And 4.38 we have as blue. So here we see that these colors are not matching each other. I should choose the proportion that has the colors corresponding to each other on top of each other. So for instance, when we look at B, if we're going to do it the first way I showed you, I'm checking to see, do I have V and 2.52 diagonal? I do have V and 2.52 diagonal. And when I have V and 5.252 diagonal, I should also have 6 and 4.2 diagonal, which I do see is correct on this proportion, which tells me that B is going to be my answer. But again, I'm going to go ahead and show you doing the color coding as well. So if you are to look at B, we have V, which is, we colored that side as green. 6, we also colored that side green. So we see that these two are corresponding to each other. And this proportion is equal to 4.2, which is orange, and 2.52. So again, here we see that these two sides have corresponding sides because they are the same color. And again, B is your answer. But again, if you set up your proportionality ratio, you would see that we have V is diagonal to 2.52. And when we have V and 2.52 diagonal, we should also have 6 and 4.2 diagonal, which is what this proportion shows. So again, B is your answer. Let's go ahead and look at number 3. So for number 3, it says figures 1 and 2 are similar hexagons measured in units. Which proportion is not true? So again, we're going to go ahead and start by setting up a proportionality ratio. So we have figure 1 over figure 2. So again, you're going to need, for this one, since we are creating a hexagon, you will need 6 different colors. And I'm going to go ahead and start off, and I'm going to grab the red. And I'm going to go ahead and highlight the base, which is 5 in figure 1. And its corresponding side is going to be N in figure 2. Then I'm going to grab a different color, and I'm going to go ahead and highlight side 1 in figure 1. And its corresponding side is going to be 0.5 in figure 2. That is because imagine if you were to turn figure 2 to be facing the same way as figure 1, its corresponding side again would be 0.5. If I continue in figure 1, I have M, and in figure 2, I have 1.05. In figure 1, I have 2.5, and in figure 2, I have 1.25. In figure 1, we have 1.4, and its corresponding side is 0.7. In figure 1, we have 1.5, and in figure 2, its corresponding side is 0.75. So again, we're looking for the proportion that is not true. So if we were to look at F, when I have M, it should be diagonal to 0.7, which we do see is true in our proportion here. Now, when these two are diagonal from each other, I should also have 1.05 and 1.4 diagonal to each other, which I do see is correct in this proportion. So this proportion is true. Now, again, if you wanted me to color code this for you, M is green, 1.05 is green, we have 1.4 is blue and 0.7 is blue. So here we see again that this proportion is correct because they have the corresponding sides on top of each other. Okay, let's look at G. Again, we're looking for the one that is not true. So here it says when I have 5 diagonal to 0.5, which is true in this proportion, I should also have n and 1 diagonal, which is true on this proportion for letter G. Again, if you wanted to see this color coded, 5 is red, n is red, I have 1 as purple, and 0.5 as purple. So here again, these are corresponding, or this proportion is true because these corresponding sides are right on top of each other. It creates a true proportion. So here G is also correct. If we look at H, when I have 1, it should be diagonal to 1.05, which is true. Now when these two are diagonal, my proportion says that I should have 0.5 and m diagonal. However, in H, we have 0.75 and m, which is not true. These two should not be diagonal if 1 and 1.05 are diagonal. If you look at this proportion, yes, we do have m and 0.75 diagonal to each other, but these are only diagonal to each other when 1.05 and 1.5 are diagonal. To prove this to you, color coding, for example, 1 I have as purple, 0.75 we have as pink, M is green, and 1.05 is green. Here you can tell between these two proportions that we have corresponding sides, m and 1.5 on top of each other, but the proportion where we have a 1 and 0.75 corresponding to each other is not true. So because these are not corresponding sides, this makes this statement false. So here the statement that is not true is H. Again, you can set up your proportionality ratio and check to see if your sides match up to each other, or you can color code it. It again is completely up to you. If you want to see the first way I've been showing you again, I should have 1.5 and n diagonal, which is what we see here in this figure. We have 1.5 and n. And when we have 1.5 and n diagonal, I should have 5 and 0.75 diagonal, which is what we see in letter J. So this statement is also true. So again, the proportion that is not true is H.